Okay, I want to welcome everybody to a continuing series of podcasts brought to you by the Association for Supply Chain Management, ASCM. 43,000 supply chain professional members, 123,000 followers on LinkedIn, which is how we're coming to you today. So my name is Wink Williams. I'm retired Global Supply Chain Director for Northrop Grumman. And I'm very happy to have with me today Max Haot, who's the founder and CEO of Launcher. Welcome, Max.
Thank you, and thanks for having me, Wink, and thanks for everyone for tuning in. I'm here live from our headquarters in Hawthorne, California, and excited to be speaking for the next 30 minutes.
Great. So, Max, what is Launcher?
So Launcher, we're an aerospace startup. Our product, the product that we're developing is an orbital launch vehicle, or you could say a rocket, and it's focused on delivering satellites to orbit. Specifically small satellite. You know, what has happened to the industry is that satellite that used to be the size of buses have now reduced to the size of fridges or even loaf of bread. And as a result, launch vehicle can be useful at a smaller size. So we're developing Launcher Light with a goal for our first flight in 2024. And our key differentiator, you know, there's a whole new wave of startup that are trying to open space access and build new rockets, obviously, in addition to some of the existing one from ULA, Northrop Grumman, I guess, and SpaceX. But our key differentiator is we believe we can reach orbit, which is a very rare feat on a global basis, for less than $50 million invested, and that's thanks to the fact that we're building a smaller rocket, but also a lot of new tools in the supply chain, such as 3D printing and more on the design simulations and obviously smaller electronics. So 50 million investment to reach orbit would be half of the current record, which is another startup called Rocket Lab, which achieved it a few years back. And SpaceX originally had an investment of 200 million to get Falcon 1 to orbit. So one differentiator is capital efficiency, and then the second differentiator is that we believe that it's that performance is the key to win in this market. And in a launch vehicle or a rocket, the biggest passenger is not the satellite. It's about the satellite is on a low performance rocket about 1% of the total mass of the vehicle, and on a high performance about 5%. So the higher percentage of satellite you have for the rocket size, which really define the cost, it will increase your margin or allow you to reduce price. So, but the biggest passenger is the propellant, you know, more than 90%. So we are focused on not only capital efficiency, but developing 3D printed liquid rocket engine using closed cycle technology for the turbopump and copper alloy, so that we can have the highest performance in our market, which result in less propellant being used for a given amount of thrust, which result in the ability to have more satellite or more payload or a more aggressive mission in terms of altitude for a given rocket size. And we believe that once you have the design, the manufacturing of a low performance or high performance vehicle or engine is about the same. Material cost is really not a big difference in the cost. And so the winners will be the one that have the high performance design, even if it takes them a little longer to get there.
Yeah. Cool. And we're definitely going to get into detail on your manufacturing. But before we do, you know, a lot of our listeners, watchers want to know, who is Max Haot? What's your background?
So my background, I'm originally from Belgium. I'm a thankful naturalized U.S. citizen now. I've been here since 2005, and I worked for 10 years in England before immigrating here in 2005. So my background has been to build companies and product that I'm passionate about. Raise the funding, define the product, build incredible teams of experts around me, and build it. So the last two companies I built, one is called Livestream, livestream.com, which is one of the early players in live streaming platform, so that anyone can live stream an event and provide a player. We built that to a few hundred people, profitability, more than 60 million of revenue, and we sold that in 2017 to Vimeo IAC, which just recently went public. So this was mostly software, but within that company, we also built hardware. We realized that to live stream, we needed to make it easy for people to live stream from cameras, and so at that time, I built with our team. We built a live streaming camera called Mevo. You can check it out at mevo.com. I bought that back after selling it to IC Vimeo in 2017 or 19. I bought it back, and then we scaled it. By now, we've produced more than 200,000 of the Mevo camera. They're on sale, obviously, at Amazon, Best Buy, and other places. So a lot of
you still own that too.
So and we just sold it to. My focus is Launcher and to scale Launcher, and I'm a primary investor in Launcher. So we sold it in February to Logitech. I'm involved a little bit as a consultant, but that company and the team is now part of Logitech and scaling there. And we're actually looking at each other through one of these Mevo camera that can be used for live streaming or for video calls or many other things. You can do things like virtual zooms and many other features. So if you look at that scale, it was very interesting. It's a very different supply chain challenge than what we have ahead of us or today at Launcher, which is in the design and prototype phase. And it's manufactured with a Taiwanese company in China. Very high volume, and obviously some very key partners in the electronic supply chain for both video sensors, which was Sony, and also the system on chip, which is part of some of the secret sauce when combined with unique software, which is a semiconductor company called Umbrella. So a lot of very different from what we're doing at Launcher, and even the volume we expect to have at Launcher, even at the top of the success and the scaling. But a lot of great lessons in terms of partnership and high volume supply chain on a global basis from that business.
Yeah. So on the just sticking with the cameras, any supply chain lessons learned when you got into the manufacturing of those?
Yeah, it's interesting. Like in any business I build, we start pretty naive and then we learn quickly. So at first we were hoping to build the camera even in the United States. And it became very clear that the whole ecosystem and the high performance system on chip that allows us to do what we wanted to do with the camera, both the price and the capability, all of the supply chain really impose working abroad and working in China. You can't create the competing product. So what's unique to get to a point where you can create a supply chain that if you sell 1 million camera a year, you're going to be able to do it. The first lesson is to make sure you pick, the technology partner that can support you, are willing to support you, and have done it before at that scale. In the case of these partners, they had built cameras for Nest, Google Nest, also for GoPro originally. So they have the scale. So the lesson, which was not so much a lesson because it went really great, was more realizing as we were scaling from 5,000 camera a month to 20,000 camera a month, realizing how lucky we were with the partner we had, and also all of the supply chain, both for mechanical part like plastics and so on, but for electronics part. There. And then there are challenges. We had the earthquake in Japan took the sensor factory offline, and we learned about spot buying and losing a lot of margin to make sure we could still produce product because we couldn't get sensors at the time. And then recently, right now with COVID, as obviously camera are in high demand, and there's also a shortage in the integrated circuit marketplace, affecting also automotive greatly. Fighting for getting your parts, which are still tens of thousands, hundreds of thousands a year, which is I consider that high volume, but in the broader scheme of consumer electronics and automotive, it is actually not that high. So and one of the key lessons is also we have a great partner, but you can't just assume they will take your forecast and they will just buy everything on time. They have a lot of competing priorities and product. So one of the key lessons was to in-house have somebody that on a weekly basis is looking at the material buy and the lead time. And even though we were not buying most of the component for all the key ones, we had direct relationship with the provider, direct information from them, and then we could spot problems, 3 or 4 months ahead. Oh, you didn't receive the PO. Oh, the lead time is this, and we could compel our manufacturing partner to resolve that on time. So supervision and kind of being on top of the trusted partner was a key part to the success.
Yeah. So Launcher is your third startup then, right?
Yep, correct.
Yeah. And are you at liberty to say what you sold the first two startups at?
The buyer didn't want to disclose it, so
Okay.
I am not at liberty.
Yeah, let's just say a lot of money. So, which is helping you with fund Launcher, right?
Mm-hmm.
You're moving some of that money forward, and you're getting venture capital money as well. And a shout out to one of those, Boost. I'm wearing their T-shirt here in Silicon Valley. I know they're one of your investors.
Mm-hmm.
So let's talk a little bit now about your manufacturing there. So you just opened a new manufacturing plant in Hawthorne, California. You're literally eyesight away from SpaceX.
Mm-hmm.
Tell us about it.
Well, if you actually take a step back, we started a company in 2017, and the first task was build a team, obviously, that can build high-performance orbital launch vehicle. Only 11 countries in the world have ever built a rocket at country scale that can, get to orbit anything. And only, maybe a handful of private companies, especially kind of startup companies, have achieved this. So it's very rare and obviously very challenging. So we started in New York City, not by strategic reason, the best place to build a rocket company, but more by the fact that I was there with other business. And we built a small team of experts, including our chief designer, and we started testing subscale 1,000-pound thrust. Right now we're building 22,000-pound thrust liquid rocket engine, and we started testing subscale there. And so during the first 4 years where the risk is high and you have to do a lot of iteration and you're not sure what material, what 3D printer you're going to use, what design pattern, also our funding was limited, we did everything with partners. So all the machining, all the 3D printing, all the supply chain was with partners. And it was very capital efficient, but the biggest issue is that it's very, very slow. And it's also, there's not a lot of great control, especially on availability. So as part of the scaling to the next level at Launcher, we decided to move the company to, the South Bay Area, Los Angeles aerospace manufacturing and development hub here in Hawthorne is where we ended up because of this great 24,000 square foot building we managed to get hold of. But we came here, with the idea that it would be the right place in terms of the supply chain and the tools. And part of the strategy is obviously not to be doing the prototyping and development out of house, but to accelerate our development and our iteration by bringing the tools in. So right here we have 3D printers, EDMY machine, CNC machine, lathes, and we are spin forming tools, and we are adding more and more capability as well as integration space. But the key driver was really how do we go from, for the subscale engine, maybe 3 months between iterations to a few weeks because we control most of the process in-house in the machines. And then for the full scale, we are at about 6-7 months between iterations, and that's too slow. So with the 3D printer in-house that builds our combustion chamber, we think we can get to about a month to a month and a half between design iteration, manufacturing, and going to test it at our test site at NASA's Stennis Space Center. So the key is all about, we're still in the prototype stage, so it's not yet about scaling and producing, but it's about finding all the right partnership and that are local, and then also vertically integrating all the key strategic tool and increase the speed of iteration. 5-10-fold from what we had before. And back to the location, what's amazing is, in theory, we were like, oh, okay, things are, that's where the talents are and the supply chain, and meaning here where we are in Hawthorne. and it is blowing our mind. Everything is easier. We need to do CT scanning of our chamber with a $20 million machine, and we find a partner on Thursday. They CT scan it to inspect all of the cooling channel during the weekend, and on Monday we have it back, and we just drive it there. And this is happening with heat treatment. It's happening with HIP. It's happening with some of the machining overflow we have, and even our 3D printing partner. We're finding that as we are purchasing, tools, the fact that these partners have many tools within less than a mile here. It's public. For example, we've purchased a 3D printer that we use for a turbo pump from a company called Velo 3D. They're about to go public. And one of their investors is SpaceX, and SpaceX has 22 machines, 4 blocks away. So the application engineers that are helping us get going, are just bouncing back and forth between a few companies locally. So being physically in the middle of the supply chain has been a hope of our move here, but it's very concrete and very real, and I think our chance of success will be much smaller if we had not come here.
Yeah. So on the 3D printing, what are you making with your 3D printers?
So the launch vehicle is obviously the two key elements are the structures, the tanks, and the liquid rocket engine. So in our case, we are building the tanks and the structure traditionally, milled aluminum, automated welding, and we've just started the R&D and the development of that. So we're not 3D printing that. Some of our competitors have gone the 3D printing route. Only one really. Others or whether it's SpaceX or some of the up and coming companies are focused on traditional manufacturing there. But in terms of liquid rocket engine, there's been a complete change in the market that's really allowing startup like us, to build high performance liquid rocket engine for orbital launch vehicle, starting with a few millions of funding, and to make parts, subscale part, and then full scale part and turbo pump. And that really the breakthrough in powder-based, powder bed 3D printing is really completely open the industry. Traditionally, I have a part here I can show people. So this is a copper heat treated, so it doesn't. It has a bit of a oxide on it. I'll move it quickly. But this, so you can get a scale. This is about a meter tall. It's a cool a combustion chamber for a launch vehicle, 22,000 pounds of thrust. And inside the walls, you have hundreds of cooling channels and manifold that traditionally you would need to use a lot of spin forming, a lot of wasted material, and then different machining operation, and then brazing operations, which are very low yield and are very expensive and time consuming. And so that traditionally, only a few companies, in the countries have access to this technology, and it's very expensive. And now today we are able to, we've customized a 3D printer with a partner called AMCM, and we're able to 3D print the full combustion chamber with all of the manifolds and all of the cooling channels in a single piece in 10 days. And there's no tooling, right? And so as we test, this piece still has to have some basic machining operation, polishing, and then we are testing it, in August, in a few weeks at NASA Stennis. If the design is fully successful and the test is fully successful, we can obviously print more within 10 days, a few more weeks in terms of all the operations we have to do on it. But then if we need to make changes to the design, which is a key part of the development phase, 3D printing is incredible because, it's just CAD work, calculation, simulation, and then with a CAD model, you go straight to the 3D printing process. In 10 days, you have a new one. So, the 3D printing industry for our industry, especially as it relates to combustion chamber, but also the other key part of engine, which are high performance turbine and liquid oxygen cryogenic pump. Today we can 3D print, 90%. We can 3D print 100% of the critical parts. That would be traditionally, casting and forging and machining and with a lot of tooling. And so we can 3D print them now, and then some basic machining, and reduce the cost and the flexibility incredibly.
So Max, I've counted probably people from 30 different countries are watching, and somewhat, and I'll probably butcher your name here. Lunas Dane asks, do you have a project to develop your business in other countries?
Well, the orbital rocket engine and orbital launch vehicle are regulated in the United States with export control, with ITAR in the air, and that does not mean that you can't work internationally. It means that it's not up to just us to partner and sell the technology abroad. Another example of this type of technology, as you're very familiar with, are for example, jet fighter technology, right? F-16, F-35. They are abroad, but they are done through not just the vendor selling it, but through geopolitical, State Department relationship and deals with countries. So from that point of view, what's happening on geopolitical level, as I mentioned, there's only 11 countries that have this technology in-house, sovereign to them. Not all countries, by the way, can have access to land that where we can reasonably launch an orbital rocket. But there are many that have, and also that don't have the technology. During the Cold War in the 60s, 70s, 80s, if you attempted to become an orbital, space power, as they used to call it then, you could bankrupt your country. But now it's been proven that with, we believe 50 million in our case. In other case, it's been proven at $100-200 million investment range. It can be done, and as a result, you have every country in the world is interested right now to obtain a domestic orbital capability for prestige reasons, for strategic reasons. And so, we hope that when it relates to allies of the United States, that the State Department is interested to have relationship with these countries for this technology. We hope that we will have franchise opportunities in the next 10 years. And I think the demand is there. We still have to create our product, but you can conceivably imagine that we sell complete vehicle under the purview of the State Department, that we have partners that are locally building launch pads and integrating and selling and launching in other countries than here. But right now, our focus is launching and selling within the United States exclusively.
Yeah. Another question coming in from the audience, my good friend, I can call him Doctor now. He just got his PhD. David Morrow asks, did you use a special set of copper alloy with the 3D print application?
So where we are in our development cycle, and you can see at our website, launchthespace.com. So we had a test campaign at subscale. The part I've just shown you is 22,000 pound of thrust, or 10 ton for international people. And then the subscale test we did, that's on our website, is 20 times smaller. It's about 1,000 pound thrust. And so we were able to basically demonstrate 98% combustion efficiency, which resulted in a blue plume, which is, you never see kerosene engine with blue exhaust plume, and it's a testimony and a proof of the efficiency. And we did that using a readily available copper chromium zirconium, so it's not pure copper, C18150, and it's used for a range of applications, not just liquid rocket engines. So the advantage to us is that it's readily available. The supply chain is not a big challenge. We have not yet proven it at the full scale. So the full scale, we built a test stand with our first test last October, and then we have 3 new sample full scale that we are testing starting in August. And if we succeed with this material, then we will continue to use this lower cost, readily available copper alloy. Other rocket companies, with the government, have been developing, and especially with the help of NASA, 3D printed liquid rocket engine in copper. And they developed a custom alloy. NASA led that, called GRCOP. And there's a couple of flavors. which is a better material than what we use. It's a little bit more strength, a little bit more conductivity, which are really important for this application, but it's also very difficult to get hold of and very expensive. So we did not use these alloy, but we still have to prove at the full scale that we can reach the temperature and the performance with this, let's call it commodity industrial alloy. So to be confirmed, but hopefully we will use commodity industrial alloy.
All right, I'm going to shift gears here and do what I call a lightning round. I'm going to ask you a series of questions, and you just give me the first response that pops into your head. Ready?
I think so.
Last book you read?
I read one again, which is it's a book about the Manhattan Project. It's a very specific one about General Leslie Grove and how the Manhattan Project, the making of the first atomic bomb, and how in 3 years they scaled, they developed a process to separate the atom and build 10 different factories and cities at the same time, because they couldn't pick one and be sure that it would be the right one. So it's a very inspiring book. It's pretty old, but that was it. Yeah.
All right. American football or European football?
I like rockets, and I don't watch a lot of sport, but I know more about soccer than American football yet. That's one of the things as an immigrant, as you Americanize yourself, the sport piece, I haven't got that done yet.
Who influenced you most growing up?
Yeah, that's an interesting. I think it's entrepreneurs in general. Just the idea that you can go down that path of choosing something you're passionate about and doing it, and focusing on it and never giving up, and that you can make these great things that for me included, obviously building a family here, but immigrating and becoming a citizen and now building a rocket company. I don't have a specific one, but, and especially in the computer industry, I guess it started with the early days of Bill Gates and Steve Jobs, and followed by all of the internet entrepreneurs and the Google guys. And I think in general that's a big inspiration. That is, not a specific person, but a category of people and achievement that have followed here. And, obviously in the last 10, 15, 20 years, Elon Musk is obviously an incredible person and achievement to look up to.
Have you had a chance to meet him?
We've talked, yes.
Yeah, good. Favorite movie?
Dr. Strangelove. You can see a theme
nice.
here.
Classic, nice. Top moment in your life?
At the end, it's all about family. So, our kids being born, it's what it's all about. So,
yeah, nice. On average, number of hours sleep per night?
Like 6, something like that. I
good.
try more. I'm not a high functioning at very low hours, so I'll sneak in a 10 once in a while, but maybe 6.
Yeah, good. If you could have lunch with anyone, dead or alive, who would it be?
God, I should have these in my Leonardo da Vinci.
Oh, nice one. I haven't had that one before. That's a good one. Okay, so I was happy to see you have a supply chain manager on your website. That was nice to see. Mm-hmm. I also noticed you have a lot of interns. How does somebody become an intern for Launcher?
So we've been, so we arrived here and we're hiring about between 10 and 20 full-time graduates, and like between 2 and 5 year experience. So big project for the next few months is to step up the team. But last minute, as we arrived here, we had facility. In New York, we were just at an incubator office with 4 desks. Now we have 30 desks and this 24,000 square foot facility. So we opened a last minute internship, and it was amazing. We had about 700 applicants within a week from really amazing background and schools. And we picked 13, and we have we kind of nearly outnumbered between the full-time people and the intern, and it's been incredible. So how do you we'll probably open up a fall internship definitely next year, and you check out launcherspace.com, and when we publish it also on Twitter and Instagram, you apply. And for us, at the end, companies like us, or any innovative aerospace company or any company, it's all about building the talent, being the place where the top most talented people want to work for and want to work at. That's what allows you to build any product, as you mature that and scale it. So the internship program is the lifeblood of how you go from a company with 40 people to one with thousands, without lowering the quality, more with the opposite, right? With being able to build more complicated machines in high scale. And related to supply chain, right now we are in the prototype phase, and so it's actually the more we realize it's really critical to get somebody on board now, or at least that's our lesson learned, that since supply chains are so local, especially the ones that are the most useful, meaning that it can go very quickly, which is our objective, because your partner is down the road, you can trust them, they have the assets and the machine. For us, the next step on supply chain is to find somebody that is knows inside out, within 100 mile, all of the assets and tools that could be useful to us and the partners, and build this partnership now, even though, which can be challenging because we are at the prototype stage and a lot of vendors, as are focused on serial production. So, building a team that can help us identify these partners, and, bring credibility and motivate these partners to want to work with us for the future. That's our next step in supply chain. And then obviously, as we'll get to make 20, 30, 40 vehicle a year, and probably of bigger size as we go, then we're going to need a big team that does that. So right now the key is it's like the entrepreneurial aspect of the supply chain, how to help us find the right partners. So
yeah. Well, I'm sure there's a lot of ASCM supply chain professional members that just watch this going, I want to come work for that guy.
Well, if you know the South Bay, ecosystem, and you're interested for the startup, phase of your career, max@launcherspace.com. Just email us. So it'd be great. And sorry.
So last question for you. If you had a message to share with all the thousands of people watching, what would you like to share with them?
Well, that was the thing we talked about. Join us if you can help us, was the key selfish message, and related to supply chain and startup in aerospace, a quick parting thought, and we actually have to be really thankful to our neighbor SpaceX and Elon Musk. But when they started in 2002, when obviously the only people that were making products were the primes and they were credible, the stories recounted by ex-staff in the books is that SpaceX, with $100 million in the bank account, could not get valve vendors and typical vendors to even return their call or supply them. They even have to buy valves on eBay. That's some of the stories of Tom Mueller, and because of what they've achieved, right, from a startup to what it is today. The whole industry, including the Space Force, by the way, which we won a grant from, which probably wouldn't have returned call or the Air Force at the time of SpaceX in early days. The whole industry has basically realized, hey, this could be like the internet. This could be, we have to work with the small startups, the innovative one. We'll work with 10 of them, and maybe 2 will make it. But out of 10, one will become the next SpaceX or the next Northrop Grumman, or Grumman, I guess, and maybe Northrop, I don't know the history so much, was a startup on Long Island when it all started. So I think it's really exciting that our interaction, when we started in 2017 and today, with all of these vendors, some are small, $50 million a year business, some are $1 billion businesses. All of them are realizing that even though we're small, even though we are low volume, they can't afford to not work with us, and they actually want to work with us to see whether we can succeed and help us. So that's been a big change that I think is making it even more possible to achieve great things like building an orbital launch vehicle with limited funding.
Yeah. So I know you're heavily into space, and you mentioned to me that you went over and saw the James Webb Space Telescope, but from the outside, looking in the window there, right?
Yeah, yeah.
So as my gift to you, the surprise I told you I had for you, I have the project manager is going to take you on a private tour of the James Webb Space Telescope and program. So
Wow.
we'll get that set up.
I am,
So,
wow, thank you. That would
yeah.
be, obviously that both from a personal interest, it's one of the most incredible payload ever built, but from a professional as well, it's a great privilege. Thank you very much, Wink. I really appreciate it.
Thank you, Max. Thank you all for joining in. Continued success to Launcher. I look forward to hearing of your future successes. So anyway, thank you, Max, and thank you everybody for joining.
Yeah, thank you. Follow us on Twitter, and you'll see our tests and results as we progress. So thanks for watching, and thanks for the interest, and thank you, Wink.
Okay, time to hit the power down button. Here we go.
Great, thank you.